So this video is going to be a little bit different than our usual videos because I am physically here instead of just on the screen. So we are going to be using these algebra tiles, and I wanted to give a tutorial of how to use them, and the best way to do that is physical. So these are algebra tiles. These represent x squareds, these represent x's, and then these little ones represent just ones. So I'm going to switch back and forth between, you can see the algebra tiles and the paper that, well, it'll be your virtual notebook, but it's my physical one right now. So this, the side lengths of this are x and x. Let's shift stuff over a little bit so we can write some stuff down. So side lengths are x and x. So the area of this is x times x, which would be x squared. The length of this is also x and 1. And 1 times x would give us x. Finally, these little ones, the side lengths are 1 and 1. So the area is 1. So the red sides of these algebra tiles are going to represent negatives. And here is a key feature of algebra tiles. While it's super tempting to try to line up enough of these ones to make an X, they are just slightly off, which means that there's no amount of ones that are going to line up to be an X, which makes sense. An X is unknown, so we wouldn't know that how many ones it was. So you cannot put ones on an X side. So what are we going to use these for? Well, we can multiply together expressions or just numbers, or we can find the factors of real numbers using the tiles, and we'll go through what that looks like. You can switch from polynomial or standard form to factored form using the tiles in a process that's called factoring. And again, I'll show you what that looks like. You can then switch back from factored form to polynomial or standard form using the tiles in a process called expanding. So let's say that I wanted to show an area model that's multiplying the numbers 2 and 4 together. So we'll use something concrete. So I'm multiplying 2 on one side by 4 on the other side. It doesn't matter which way these go, but since I have a longer box, I'll do the longer side. Yes, I should have them all flipped over, but it's fine. So multiplying 2 by 4 2 times 4 is obviously 8. That means that we have 8 tiles that we can arrange in a rectangle with side lengths of 2 and 4. So it's called an area model because it shows you the area of the rectangle. And remember that area is calculated by multiplying the side lengths. So now let's show an area model that shows factoring 10. So I've got 8 tiles here. Add 2 more tiles. So I could factor 10 2 different ways. I could factor 10 in one long rectangle, right? That would be a way that I could arrange my tiles into a rectangle of 10. This rectangle has an area of 10. I could also arrange my tiles in a smaller rectangle. Area is still 10, but now the side lengths instead of 1 and 10 are 2 and 5. So let's sketch both of those area models. So the first one is a long one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1 and 10. Our other option is 2 by 5. So factors of 10 are 1 and 10 and 2 and 5. Okay, so now let's start introducing some x's. So I want to create an area model that shows multiplying x plus 1. So this would be x plus 1 times x plus 2. So my other side is x plus 2. So let's go ahead and sketch this out. So I have my x's, my 2's, my x, and my 1. So this is x plus 2, this is x plus 1. So now let's calculate the area of this. I know from up here that x times x is x squared. X times, side length of each of these is 1. So x times 1 would give me x. X times 1 gives me x. Now it doesn't matter that this is flipped on its side. It's still also an x because x and 1. And then my little ones here, as we said earlier, are 1 and 1. So I have an x squared. I have an x, another x, and then 2 1s. And if I combine my like terms here and here, I'm going to get x squared plus 3x plus 2. So that is how you would multiply 2 binomials together to get your polynomial or your standard form. Here's what we're mostly going to be using these algebra tiles for, is for factoring. So I am going to count out an x squared, a 5x, and a 6. And I'm going to do this here. So I have an x squared. I have 1, 2, 3, 4, 5, and then 6 little pieces. Our goal is to arrange these into a rectangle, a complete rectangle, like we have here. So we're going backwards. We have all of these pieces. We're trying to arrange it into this complete rectangle. So easiest way that I've found to do this is to line up all of your x's on one side and see what happens. Remember that I can't put x's or 1s along an x side. There's no amount of 1s that will perfectly add up to an x. So I'm going to stack all of my 1s here. Okay, this does not create a complete rectangle for a number of reasons. 1, I got a gap here. 2, I got a gap here. So I'm going to shift one of my x's down here, so that solves that gap, but I've still got these two here, which I'm going to stack under. Okay, still got two gaps, so I'm going to shift again and fill in, and there we go. We've factored it. We have a complete rectangle. There's no gaps. There's no ones along a long side. So this is completely factored. Let's sketch this out. I'm afraid I'm going to mess it up. Shift you off to the side. Okay, so sketching out this area model. So we have our x squared, we have an x, an x, an x, an x, an x, and then 1, 2, 3, 4, 5, 6 x's, or 6 ones. The length of this is x. The length of each of these is 1. The length of this is also x. The length of each of these is 1. So if I have x plus, that's x plus 3, and then x plus is x plus 2. I should really put some pluses between here. So factored form is the length, the side lengths, just like up here the factors were the side lengths, same thing here. So factored form is x plus 3, x plus 2. And it does not matter which order these go in. It could be x plus 2 and x plus 3, as long as you're listing out these side lengths. So that's how you're going to factor. Now things might get trickier because you might have to be dealing with some negatives on both sides. If we have to deal with negatives, I will give you, or I won't give you, you will want to color in your physical page with some red marks to indicate that they are in fact negatives that you're dealing with. But that's a basic tutorial for how you're going to use Algebra Tiles.